All right, hey everybody. We're going to be working on the same standard that we did in our last video, determine the solutions to linear equations. This is video 1.2.2, that's Unit 1, Standard 2, Video 2. And this one is going to be talking about equivalent equations. So go ahead and pause if you need to write any of that down on the top of your paper, and then we'll get started. Okay, so we're going to go ahead and solve this. We're going to use the methods that we did in the last video using the inverse operations. So the first thing I have to do is get all of the x's into one spot, and I'm going to go ahead and do that by distributing the negative 2 on the left-hand side. So I will have negative 2x minus an 8 plus a 3x equals x minus 8. I'm going to go ahead and combine the x's on the left-hand side, and that leaves me with an x minus 8 equals x minus 8. And before I continue with this process by moving the x's to the one of the sides, what I recognize is I end up with exactly the same expression on both sides. So this is an example of an equivalent equation where I've got this x minus 8 and x minus 8. So what we recognize is it is itself. And when something is itself, we actually call it an identity. So this type of equation is called an identity. What is it? What type of solutions does it produce? Well, if I were to go ahead and substitute in a 5 for x, I would have 5 minus 8 equals 5 minus 8. That would be negative 3 equals negative 3. And you'd say, well, that's true. And I said, oh, okay, well, let's try another one. Why don't we try 15 minus 8 equals 15 minus 8. You'd say, well, that's 7 equals 7. And that's true. In other words, there's not a single x value that I cannot choose that wouldn't make both sides of this equation exactly the same value. So this solution, or the solutions, are all real numbers. And another way of saying all real numbers is a symbol we learned in our very first video, and that is the double R. So let me point out that the type of equation that we're working with is called an identity, but the solution is that there are all real solutions. Let's try another one. Okay, this looks like a pretty basic equation. Let's go ahead and solve it. I am going to use the inverse operation method for this one. So I'm going to say what happened to x. I multiplied x by 5, I subtracted 4, and I got 11. Working my way back up, I will add 4 and get 15. I will divide by 5 and I will get a 3. So x equals 3. We came up with a single solution. Not every number will work here. If I were to substitute a number other than 3, for example, let me substitute in the number 2, I do not get 11. Okay, I get 6, and 6 does not equal 11. So not every number will work. In fact, the only number that will work for this one is x equals 3. This is called a conditional equation, because it takes a special condition to make both sides the same. Remember, the goal is to have them be equivalent on both sides, which means they have to have the same value. And in this case, it's a special condition that makes that happen. The condition is that x must equal 3. This is a conditional equation. Let's try another. Take a moment if you need to pause to write this equation down. All right, so if we were to go ahead and distribute on this, because we would have to in order to get the x's into one location, is I would have 9x minus a 3 equals 9x plus 7. And I'm looking at this going, this kind of looks like the first one, which we called an identity, except I have 9x minus 3 and 9x plus 7. So think about putting a value in for x. Let's put in the number 1 for x. So we'd say 9 times 1 minus 3 and 9 times 1 plus 7. So whatever this 9 times 1 is actually the same, right? It's the same, But then I'm doing something different. The second operation on the left-hand side is that I subtract 3, and the second operation on the right-hand side is that I add 7. So can we think of a value that when I get this thing to be the same, and I subtract 3 or I add 7 and I get the same result? And the answer is this will never happen. Okay, so if we were to continue and I were to move the x's to the same side, if we were at this stage right here, and I were to move the x's to the left-hand side by subtracting 9x from both sides, I'd end up with a statement of 3 equals 7, and you'd say, well, that's not true. I agree with you, it isn't true, which means that this is called a contradiction. Okay, a contradiction. Now, why is it a contradiction? Because in the beginning I told you that these are equal. And in fact, there's not a single number that actually produces both sides of this to be the same, which makes it a contradiction. There are no solutions. So again, the type of equation we've got is a contradiction. The solutions is that there are none. Let's go ahead and summarize all of this. So we actually have 3 different types of solutions and 3 different types of equations. So if we talk about the type of equation, versus the type of solution that is produced, this will help you when you try to communicate answers, because the type of equation is just describing the equation. If I ask you to solve, you're going to not want to use one of the words from the left-hand side, because I'm talking about a solution. If I ask you to describe the equation, you'll use one of these 3 words. We had the identity. And the identity was when both sides were the same. And that produces all real numbers. Okay, and that's our double R, that all real numbers. On the other side is the conditional. And our conditional was when we came up with a single solution. Okay, because our linear equation had one solution. And that would be x equals whatever that value happens to be, whether it's an integer, whether it's a rational number, we come up with one solution. And the last one is the contradiction. Okay, and our contradiction gave us no solutions. All right. Well, that ends this video. So if you have any questions or if you want to make any comments or help out another peer from the class, go ahead and post those on Schoology on the discussion board. And also go ahead and work on the entrance slip just to do a little bit of check to see how you're doing on this particular topic.